Okay, we're solving equations with complex numbers. In this instance, we have 2x squared plus 27 equals 0. Now, one of the first things I usually do is I start to factor it or factorize it so I can start to find a way where I can put it into a formula like the sum of two squares or the difference of two squares. In this instance, it's going to be a bit challenging. I've got a shortcut, easy way to do this. What I'm going to do is try and isolate the x squared on one side and the numbers on the other side. So this is the way I would like to do it. So let's say we're going to move the 27 over to the right by subtracting 27 on both sides. So I'll subtract 27 there, subtract 27 here, and bring it over to the right-hand side. So that means on the right, we have 2x squared, and that equals, well, positive becomes negative, negative 27, like that. So what we want to do now with this is divide both sides by 2. I want to isolate the x squared. So dividing by 2, if I divide by 2, now divide by 2, that's going to give me x squared is equal to negative 27 all over 2. So I want to get x by itself, so I'm going to square root both sides. So let's square root there, square root there. That's going to leave us with just x on the left-hand side, which equals the square root of 27 times the square root of negative 1. Negative 1 times 27 is negative 27 all over. Now the whole thing has been square rooted, so the denominator is the square root of 2, like that. Now what does that equal? Well, that equals the square root of 27. Square root of 27, how would we write this in radical form? Well, we could simplify it by breaking it up into numbers that multiply to give me 27. So one of them could be a perfect square, like 9 times 3. Now that's a perfect square. Square root of 9 is 3, so this becomes 3 root 3. So we could replace the square root of 27 with 3 root 3. So let me go ahead and do that. 3 root 3. And we also have the negative 1. You may recall from other videos, the imaginary unit I equals the square root of negative 1. So we can replace that with a negative 1, with a I. We can replace it with an I. There's our I. Let's put an I there. All over the square root of 2. Okay, that looks pretty good. 3 root 3i all over the square root of 2. But there's a bit of a problem. We have a denominator that is irrational. It's the square root of 2, the radical of 2. So we want to rationalize that denominator. So we need to multiply top and bottom by the denominator, which is we multiply by the square root of 2 and the square root of 2. Let's rationalize it. So let's multiply these two guys. That's going to become 3i. That stays the same. 3i root 3 times root 2. 2 times 3, because they're both under the house. 2 3s are 6, so that's the square root of 6. All over. Square root of 2 times square root of 2 is just 2. Okay, now we're starting to get a solution. So x equals, we're going to have 2 because it's plus or minus. Let me put the plus or minus there. It's plus or minus. Once we get the square root, it's plus or minus. So all of them are plus or minus. So x is going to be, one of the solutions will be 3i root 6 all over 2. And x, the other solution, will equal 3i negative 3i square root of 6 on 2. Let's have a look here. That's our two solutions. Root 6, root 2. Yep, that's correct. So we've got two solutions and they're both imaginary.